Hi and welcome back to a new video. The Intel 270K Plus has been out a couple of days now and I also made a review, but what is typically hard or even impossible for me to tell in a review is what happens for availability and pricing. Of course, Intel said it should cost about $300, but we know from NVIDIA GPUs that imagination and reality are often far apart. But at least here in Germany, looking at Geizhals, it seems to be kind of accurate. So the CPU is currently listed for 319 euros. And what surprised me, it's also the most demanded CPU in Geizhals in Germany. It doesn't mean that it's the most sold CPU, it's just the most requested. And I was surprised, I'm being honest here, because I thought that 1851 just stays dead on arrival and nobody is ever going to use this platform again. But now, price performance wise, super interesting CPU, great performance, and I want to check today what we can do overclocking wise, because just from the specs, the 285K is slower, but we saw in most of the review that the 270K Plus is actually faster. Still, we should be able to match the 285K with overclocking and then see how much we can push out of the CPU. Also do delidding. That is something I haven't done in a long time for 1851, also because it's super complex. Thermal Grizzly Duronaut is our new high-end thermal paste and the successor of Cryonaut. It's even better performing, it is much easier to apply, it is cheaper, and it's much more durable. That's where the name comes from. Especially if you're now maybe considering to buy a new PC, then I would highly recommend that you're looking into this thermal paste. So let's continue with this video. But before we start with the lidding, we will first test it with normal water cooling. So we have our Intel Mycro Pro water block on this, and it's powered by the Mora 600, which I have mounted on the wall. So this should already give it some thermal headroom. I'm still using my setup from the review, so it's still the same Pro WS C890 Ace SE motherboard, which is not what you would call an overclocking motherboard, but I'm being honest, like these days, all the high-end boards are capable of just pushing the CPU and you're just in the end mostly limited by the CPU silicon quality itself and not by the motherboard. And yeah, we still have our water block mounted. If you want to see the assembly of this setup, you can check this out in the review that we posted a couple of days ago. For the 270K Plus, I experienced a performance that was already beating my 285K at stock. So my 285K was getting about 42,000 points in Cinebench R23. And as you can see here, my 270K Plus scores about 44,000 points. So that's already 2,000 points more than a 285K just running stock. I then performed a manual overclock, so I switched to Asus Advanced OC Profile, loaded XMP2. Well, XMP was already loaded before on stock. And also then pushed a CPU to 5.7 on P cores, 5 GHz on the E cores. Also manually adjusted the other clocks such as cache fixed manually to 4 GHz, NGU to 3.2. CPU D2T to 3.4 GHz, and then also gave the voltages a little push, at least for P cores 70 millivolts offset, E cores 110 millivolts offset, and then fixed the input voltage to 1.45. I also unlocked the power limits, which is necessary to make sure the CPU is not held back by this, but this is now also a static overclock with like fixed clocks and voltages, which is something you can definitely improve for daily use. For this, I would strongly recommend that you visit the Cinebench YouTube channel. He has deep dive videos about how to tune your CPU perfectly, like an hour-long video, and there you can tune it more towards daily use, but this is better for just straight up YouTube comparison video, especially for temperatures and also performance. So later when we want to jump to the lidding, it will just give us easier numbers to compare. Before we do any real benchmarks, it's absolutely important to first check your thermals and limits, but this all looks good here. We see some of the P cores being a little bit hot, like P core 13, 82 degrees Celsius. We can also see the CPU is not limited anywhere, like thermal throttling or power throttling. That is absolutely important. Also, yeah, 300 watts package power draw. And we can see under load that the CPU is clocking at an expected 5.7 on the P cores and 5.0 GHz on the E cores. And we will obviously double check this with a 10 minutes test of R23 to make sure that this is also stable and then see what kind of thermals we will see after about 10 minutes. After almost 9 minutes in our 23 loop test, you can see this is still stable for the P clocks at 5.7, E clocks at 5.0, but it's close to the thermal limit. You can see, for example, the P core 2 is hitting 86 degrees Celsius, so there is not really thermal headroom left to push this any way further. But what I find quite impressive is that the average power consumption right here is 311 watts, and a peak is almost 400 that I was seeing. Now, of course, we want to find out what kind of performance do we get when hardware info is closed. So we have a clean run with our normal water block attached, and of course also powered by a Mora 600, which will give us significant thermal headroom, and we can see 47,000 points in R23. I'm still impressed how cold the CPU is running in this state. It's pulling more than 300 watts, and on average it was 96 degrees Celsius. The peak was 86 with one of the P cores, but the majority, especially the E cores, are staying a bit colder, which is why the average is dropping to 69 degrees Celsius. But yeah, that's basically the limit that we can do with the CPU without touching it further, without delidding, and that's something I haven't done in a while for 1851. Yeah, with a heater. That will be interesting again. It has been a while since 285K delidding, so I want to remind you of some of the aspects. So back then when we made the delidding tool for the 285K, it was early that Intel told us that the CPU might get damaged from simple moving heat spreader back and forth as we do it, for example, on Ryzen 9000. And they pointed out that the CPU might be too fragile for this. So we came up with the heating solution, which means that the CPU is being heated to about 170 degrees Celsius. So the indium that is connecting the silicon chips with the heat spreader is melting. Then you move the heat spreader once in one direction to loosen the glue. And then you heat up the CPU again to be able to remove the CPU from the heat spreader. CPU has to first go into the delidder. You just do it according to the triangle marking, so you can see the triangle marking in a corner. Make sure that the CPU is sitting properly. Add the slider in the same direction, and then add these things to the side. That's how it should look like. You also only need one screw on one side. Back then in development phase, we just didn't know if we might need a second side later for a different CPU or whatever, so we wanted to keep it universal. Turned out we only need one side. And with this, we're getting over to the Diamond Heater V1. And this is still one of the craziest products we ever made. First of all, because the market for this is like a handful of people, and it is super special, right? Nothing I would recommend for the normal user to do, but it just feels cool that we were able to make this even as a product, and me being able to show this on a YouTube channel to just show what's theoretically possible. And that's our control unit. For this we will need an USB-C charger, at least 65 watts. Inside here we have a heating element that will have thermal contact with the delidder. We will also add a little bit of thermal paste on here to improve it. And then we have this temperature probe, temperature sensor that will have contact to the back of the CPU, and it's absolutely important to check that the sensor also has contact with the CPU on the back. I also recommend to add a little bit of thermal paste on this. That's also why we have the small window on the back, so you can check this has contact to the back of the CPU. It is important to put it on something heat resistant because it will reach like 170 degrees Celsius to make sure it's not melting your desk mat, for example. And now attached to USB-C, you can also see everything is detected properly. You can configure this if you want to manually, but it should not be required. You just have to press this button and it will start heating. You can see it reached 50 watts of heating performance. It is also counting in time, just to make sure that, for example, if you missed something, if the temperature sensor is not properly connected, it will also still shut down after a certain amount of time. And now it's heating up. You can see it's already at 30 degrees Celsius. At this point, you should also wear some gloves because this will be hot, and we will have to rotate this screw a little bit to make sure that the slider is moving towards the right. If you have, you can also add a second thermometer just to double check temperatures. The slider will be usually the coldest part of the delidder because it has the latest contact with the heat. So heat first goes to the base of the delidder, then through the CPU, then through the slider. We can see it's now at about 65 degrees Celsius, while this is reading 72, 73. So there's about 7 to 8 degree temperature difference, which makes sense, but we have a target temperature of about 165 degrees Celsius, so that should be good. already reached 100 degrees Celsius. But you can see it definitely takes some time. It's like 13 minutes already, and we are now just approaching 145 degrees Celsius, but we need 160 degrees Celsius at least to be sure. We had to wait almost 1,000 seconds, so that's almost 20 minutes. But it's now at 163, so that should be good. I will switch it off over the button and then move it. I could hear a click, and it didn't take much force to move it, so that is a good sign. Now we have to take the CPU out. Ideally, you should let it cool down for easier handling, but it then will also take more time. And you can clearly see that the IHS moved a little bit to the left, but it's now sitting solid again. So we have to place the CPU again on the heater, this time with the IHS making contact with the heating element. Make sure the contact is there between the temperature probe and the IHS. And once this reaches about 160 degrees Celsius, we can lift up off the PCB. Double check from the bottom. That should be good. Now we have to restart the heating element. You can see this is still hot. And also this time it will be much faster because it's much less mass. It says heating done. And there we have it, the 270K plus result looks really good. Now there's obviously some indium left on the CPU, which we will first try to mechanically remove carefully and then also chemically with liquid metal. And I also just have to tell you that this kind of hardcore modification is just a lot of fun to do. I have to admit that. Glue is removed, and that's also one of the critical parts where you have to be super careful not to knock off any of these SMDs from the edge of the PCB. Now we will dissolve most of the remaining indium with liquid metal. Now there's still a top layer of indium remaining, and we will have to polish that away. For this I will use a product that we did not launch yet. It's coming soon. Looks good already, but you can see left, right, there is still something that appears to look goldish. So we still have some metal layer left on there that I still want to remove. That's good, no more residues, so I can now clean it one more time with IPA and then apply the liquid metal. Now just hand tighten and we're good. This took quite a bit longer than I actually expected. Just quick check without the water flowing just to see if everything is fine, but it looks all right. Now also again with water cooling, and great, everything is alive. Now I'm just rerunning Cinebench R23 at the same settings as before. It's again the overclocked state. The temperatures already changed quite a bit, as you can see. Just above 50 degrees Celsius. So that all looks good. Clocks are still the same. I will just rerun the 10 minutes test and then we should know more. It's again over 8 minutes and we can see a drastic improvement in a max temp of about 22 degrees Celsius, average about 17 degrees Celsius improvement. It is still the same condition. You can see CPU package power draw is improved a little bit because the CPU is now running colder, average about 290 watts, peak 370 watts in R23, but still same scenario, still running same voltage as before, same clock, 5.7 on the P cores, 5 GHz on the E cores. Back then, when I was delidding my 285K, I was able to achieve 47,600 points in R23, and I want to beat this now with a 270K plus. We have a bit of thermal headroom. This means we can push voltage and clocks further. It is crazy what this CPU is able to achieve. 49,000 points. And that was possible by having 5.8 on the P cores and 5.3 running on the E cores. Slightly increased voltage, as you could see, but still at least okay to run some benchmarks. That means with all the modifications we did, both physically and also in BIOS, we are able to push the 270K plus by about 11%, so from 44,000 to 49,000 points, which is also more than I ever achieved with my 285K. Obviously also comes down to Silicon Lottery, but I would say it just confirms that the 270K plus is nothing else than just a rebadged 285K. And you can expect pretty much the same thing for just above 300 euros. It's mind-blowing performance for the price. I hope you enjoyed this. I also enjoyed doing this kind of hardware modification, hardcore modification. Again, didn't do it for a long time, but it was a lot of fun. See you next time. Bye-bye.